Very good afternoon to all of you. And as Professor told that you had so many learned speakers, and they have told you so many things related to AI and machine learning. So let me try this afternoon to give you just a glimpse of this information retrieval, and it's especially machine learning based information retrieval. So, really going to my presentation, before going to that, I just want to add a preamble. Preamble to this is that it is related to one of the DST project that I have undertaken with my team. And it was just kind of that my students used to come to me for getting letter of recommendation for getting admission to various foreign universities in US or UK or in Canada. Many students, and after doing their graduation and after maybe serving for 2 years, 3 years, normally students used to come back that we are going to this Georgia Tech, or we are going to Harvard, or we are going to MIT, means for masters, and they wanted that LOR. And they used to tell me that many students from IITs, they have their seniors in those universities, and they do place their applications and their LORs in the letterbox of professors there. So that's why they get the advantage of that. So means it was something kind of that in my mind that if we create a database, or ministry creates a database, that there are all in that database, there are all professors who are from Indian origin, maybe professors, scientists, or associate professors, assistant professors, means all faculty and scientists in that database. And anybody from India, students, professors, or scientists, PhD scholars, they can have information of these all professors, these people, and they can get benefited from that. Okay, this Indian origin people, they are for years they have been settled there, and they are doing really wonderful work there, research and academics. They are doing wonderful work there. You will come to know when I'll discuss with you the whole details of the database which we have retrieved. So means if you are aware of that, presently in the US, their National Science Foundation, that president of that is a Indian from Tamil Nadu, that he is heading that MSF, which is the most reputed National Science Foundation. That it's a funding agency for science and STEM projects in US for all universities and all. So means it was kind of that, and then we checked some world-known universities who are in these Times ranking or in QS ranking. They are on top. So we just tried to explore, and it was really surprising. Business school is completely run by Indians. Means their dean is also Indian, and 27 full professors are there in that Harvard Business School. Because earlier through newspapers, I came to know that $25 million Tata's they have donated there in Harvard Business School for a certain project. So I was thinking that why they are not donating it to Indian universities, because we are in need much more as compared to Harvard Business School. But when I was doing this project, I came to know that the way that Indians they are doing there. So then I could get that justification that why Tata's they donated there. Okay, so let's start with this, and we have around 30,000 in our database, 30,000 academicians who are of Indian origin. And for 4 countries we have already done, and for 6 countries we are doing now. So it's a DST funded project. So for 4 countries, US, UK, Canada, and Australia, that we have already done. So about 30,000 Indian origin academicians are there in our database, and within a week or 10 days, it will be launched formally by Government of India. It will be available on DST webpage, and you can search also. And there are many government schemes are there, like GAN, in Gyan, any engineering institute in India can invite any professor abroad and working in any university, and they can host them for say 3 months, for 2 months, for 1 month, for teaching any course. See, only few IITs in India, they have the contacts in these type of world-renowned universities. But what about the other rest of India? Because actual India is not in only IITs; it is beyond that also. So many engineering institutes are there, polytechnics are there, other institutes, universities are there, and you will see those are the things that I show you. The agenda for today is brief introduction that we have already discussed, and further also I'll discuss. For information retrieval, there is a crawler. Means the people who are working in, who have done some scraping or some Python library they have used for retrieval of information. So they must be knowing that any search engine, if it is working, so on back end there is a crawler who will actually number crunch or character crunch that information and then will bring the raw information after crawling that. And then I'll discuss the methodology that naive-based machine learning algorithm we have used for that. And then because after a certain period of time, any database that becomes obsolete. So we have kept a automated module to check the change, all changes in those URLs from where we have retrieved the information. I mean, these were the objectives for this particular project: to compile the data of Indian scientists and academicians working in foreign universities and research laboratories in various disciplines of science and engineering. Then we were to create one MIS and then to design and develop a user-friendly GUI so that we can facilitate all stakeholders. Okay, then mobile app was to be developed, and then through that we had to create a blog also, so that the Indian students and different researchers, they can collaborate with them and they can discuss on a common problem. Okay, and then we have to showcase the achievements of Indian women scientists and academicians. Then what I've done is that you will see that it's more than this. As I told you, about 30,000. And it was that earlier we started with only academicians and scientists. But then one day we received a note from PMO office through DST to retrieve the information of PhD and MS scholars also. That Government of India required that information also. So we developed crawlers, 3 crawlers we developed, and they all are machine learning based crawlers. So we will discuss that. And all this, that GUI we have created, that just one glimpse of that, and then mobile app which we have already created, and it will be available. Okay, then showcase that as I told you that, and we have to highlight the women scientists, their achievements. This is the basic crawler. Okay, basic crawler architecture. That how it works. Okay, that how it works, because through internet you will get the seed URLs. Okay, there is SEO quick application is there, API is there, and through that first we need to retrieve, because our search domain is academicians. So only academic URLs, that academic universities are our seed URLs. So through this SEO quick, we can API, we can retrieve all universities in US, UK, Australia. So country-wise, we retrieved those all URLs. So these are the multi-threaded downloader is there. When if you want to download the whole content of a particular URL, or you want to just crawl, then scrape that URL. And the scraping is like our data students, they are working on these different types of scrapers, and all these companies you can name: GS, JP Morgan, okay, then BCG, that consulting company, Berkeley Consulting Group. All these, even Price Waterhouse Cooper, PwC, they all are using scrapers. And all your stock exchange and these all, they need to go through different information, and that information, focused information through focused crawlers, that can be retrieved related to a particular topic. You will get certain information, URLs will be added to a queue, and one by one scheduler will pick up and you will get the data for processing. This is the basic crawler that on Google if you want to work. And then the kind of methodology, basic methodology that will be, the crawler will get these all URLs, all web pages, and URL extractor will pick up one by one, and all URLs will be there. Then they'll be distilled, they'll be filtered. Because what we are to do, we are to remain in academic website. Okay, because you can think of when Scraper it's crawling a website, like in Carnegie Mellon University, we could find around more than 20 lakh URLs, 20 lakh. Because crawling, it's not that easy, that manually we cannot do. So in one website, if more than 20 lakh, rather I'm saying they were more than 20 crore. Okay, so then we reduced it to 20 lakh through different distillers and filters. So because it is, when it is crawling one by one, each and every word and each and every line, so it may go out of that domain also. Because in one university, you may have URL of any conference, or maybe that URL you have certain, any professor or faculty, they have given their Facebook URL also, LinkedIn URL also, or there may be fee payment URL which will take you to a bank domain. So we have to take care of that it will remain in the concerned focused domain only, so that if it is say harvard.edu, so it should remain in harvard.edu or cmu.edu. So it will remain into that. It will first extract all URLs, and then distiller will take care of and will filter all the relevant seeds. And then these relevant seeds, they may go to the classifier. Okay, to classifier. And we need to see, okay, let's see. Because highly irrelevant, as I told you, banking, Facebook, or LinkedIn, then it will be infinite kind of crawling, infinite loop. So you will not be able to come back. So that distiller will take care of that your domain will remain .edu or it is cmu.edu, that you are not going out of that. As soon as you will jump out of that, so it will stop. Okay. So then classifier classifies the web pages as relevant or irrelevant based on the, because we need academician pages, so it will take care of that. So it's not going to any conference web page or any student event is going on, sports meet is going on. So many URLs will be there in that website page. So to avoid that, so all those irrelevant URLs, so classifier will take care of that. And then classified pages will be there. And for classifying these, you need certain input data or training data set. Okay, so those all input data sets we have used. I'll tell you later which type of data set we have used. Now, the main motto of distiller, as I explained you, the time to time system may go out of that domain. Okay, and then this crawling is not that easy, that only one CMU page, it took around 9 days. And 9 days, it is not 24/7. Okay, 24/7, that machine was on, and then it will keep on crawling and it will keep on returning that. And sometimes if there is we face those kind of problems also, there is a power cut. So it will again start from beginning. So to avoid that, so we used try data structure. So wherever there was a break, so then again we will start. So it will start from that particular thread only, from that particular location only. In so much time. And various filters used by distillers are checking ELD, which we call. So it will remain into that only. No out of domain URLs, like I told you, it will go to Facebook or LinkedIn or to bank. So that will be a problem. And then try data structure is maintained for checking the duplicate URLs also, if it is already processed, or even if it is not processed, but in that list which you retrieved from that SEO cake. So it is repeatedly that URL is also there. So that will be wastage of effort. Then checking duplicate URLs that has not been processed but are present in the main, as I then discarding the URLs based upon irrelevant keywords. Now it is working of naive-based distiller. Okay, this is basically that machine learning based, naive-based. You must have done that. There is random forest also, naive-based also, SVR also. Different. These are there. So we used for because if it is very large data set, then you need this naive-based distiller will be really useful for that. Okay, like those seed URLs which were the relevant URLs. Okay, then extract. Okay, those seed URLs will come to main queue and you will extract one by one. Okay, the URL you will keep on checking. If already explored, then you can pick up the next one. If it is no, extract the immediate child URL. Okay, like if it is say cmu.edu, so next URL child can be csc/cmu.edu. CSC will be the next child, or maybe faculty.csc/cmu. So next level. So we have to check all the level of childs. Okay, but it is sometimes very difficult to go to the maximum depth. So you need to restrict the depth also then. Okay, and along with that,
நான் லாகின் பண்ண உடனே
there is some noises there, so please switch off your this mic.
Participants, please put your microphones on mute mode. Please don't interfere with the session. It's disturbing the resource persons, please.
So if it is already explored, then it will pick the next one. If it is no, then it will extract the next child level. And along with that, it is apply filters. Okay, because we have to take care of that. We are not going to any out of the range or irrelevant kind of URL, as I told you in the previous. So then filtered URLs will be there, and for this filtered, you are taking care of the classifications also, and then you check the relevancy, that whether the filtered URL is relevant or not. This keyword dataset is, this keyword dataset is there. Now, dataset, it is related to the points, subsection of university website, where the chance of finding the academicians are high. Means faculty web page is there, or you can say directory is there, or there is teaching department. Okay, faculty department. So we will not find in extracurricular activities or student section. So we need to just filter these kind of URLs out, and we have to bring in only the filtered URLs which are relevant. Okay, and then in filtered, there is consist of keywords that commonly in university website that moves the crawlers further away from the target academician pages. And for example, map is there, or there can be something kind of map events, like I told you, student section is there. So these kind of things may be there. And then it is in classifier, features of the text of the link are found using term frequency and inverse term frequency to a proper format for categorizing the URLs is relevant or not. Okay, because in this relevance, what we have done is because in training it will come in next slides to come when we are preparing the data, and then training is there. So that training for those classifiers are on the basis of Indian surnames. You'll be surprised to know that Indian surnames. So Indian surnames, it is around 10,000 Indian surnames, that database we have now. We retrieved from various websites, and then manually it was to be filtered. Repetitions were there. So then now around 10,000 Indian surnames we have, and then Indian city names. Because if these academicians are Indian origin, so they must have done their master's, bachelor's, or their doctorate from any Indian university. So we have 2,000 Indian institutes names also in our training data set, and then Indian city names are also there in our data. No, classifier is the filtered URLs are passed on to the classifier for setting the corresponding web pages that belong to Indian origin or not. Then we have identified two types of web pages in that. Central academician web page, which contains link to dedicated academician, means it is a kind of the directory, persons, okay, that kind of link if it is available, if we are lucky enough, crawler is lucky enough. Then a dedicated academician web page, like if you will go to pec.edu or pec.ac.in, you will find that in CSE, then in faculty, okay, then Rajesh Bhatia. So that dedicated web page is there. So any university, that page for one is the common page, the directory, then is the individual page. We will extract both types of web pages because they both are related to faculty information. Now, the training phase and classification phase, these two phases are there in our algorithm. Because you know, in any machine learning algorithm, there is classification and then training phase is there and then classification is there. So training web pages, that set, and you will get the feature set. Okay, stemming and stop words all need to be removed because till and until they are not removed, they may distract you. Then feature set we have identified, and then naive-Bayes algorithm we applied. And when we will get that, so then on the basis of term frequency, and that will be on the basis of the weightage, that to which particular term what weight has been assigned. Okay, because if it is a kind of that if it is there may be any professor of that Western origin, that any English professor, he has come to say IIT Madras or IIT Delhi to attend some conference, and he has presented that paper there. So even then it will leave that page. But then we have to see the term frequency and its weight, what weight we have assigned to name or to surname and then to city. So in this case, new web page and then term frequency based, that document term matrix that we will get. Collection of metrics for unclassified web pages, and then trained naive-Bayes classifier will classify these pages, and we will get the relevant web pages, and from those pages we can for faculty directory or individual faculty page. Okay, and then we will send it to the distiller. Okay, because distiller will remove all irrelevant pages and will take care of only the relevant pages. Now see, of course, naive-Bayes classifier, then a URL queue from distiller that will come, because you have seen that in distiller you will get, and then you have to dequeue one by one you will get, and if URL has been already explored, then go back and get the next one. If it is no, add it to the URL list and explore it and download that web page. Then stop word elimination, that was first step, that all stop words and white spaces you have to remove. Calculate the probability of relevance for the web page. That relevancy you have to calculate, and you will get the training data. The training data will, and from that training data, I told you that for data, those all surnames and all that we will use, and extract links and pass to the main thread. When you will compare it with the threshold value, that whether it is the relevant page or not, okay, then you have kept on the basis of term frequency and an inverse term frequency density, that you will calculate the threshold. If it is meeting that threshold value, then it will be set as relevant, and you will save them into relevant web pages, and you will extract further the links. Okay, they will be in the thread, and irrelevant will be ignored. See, these are the sample results which were there for Carnegie Mellon. Total URLs found during crawling. See, these are about crowd. Okay, 2 crowd links were there after using various filters. Okay, which URLs were passed. Okay, pass the filters. These are 5,90,000, or you can say approximately 6 lakh. Now, after using distiller, naive-Bayes distiller, they are left to about 1 lakh relevant URLs. So that's why I told you it's a very effort consuming task, time consuming task. So now see, relevant are also 1,85,500, about 1,85,500. Now out of that, it's only 41,000, say 41,000 after using naive-based classifier, because 41,000 are there. But as I told you, these are faculty pages, but there can be detail related to the courses they are teaching. Okay, their LMS kind of learning material they have uploaded in the system, or they have attended the conferences, their research paper publication, their projects details. These kind of information may be there. Then after using the naive-based classifier, on the basis of that, we could get 20,000. Means we started from 2 crore and we reduced it to, through this machine learning algorithms, we reduced it to 20,000. So all irrelevant kind of, because it's not only the success of the algorithm is, or accuracy of the algorithm is not only getting the relevant information. It is how to ignore the irrelevant information also. That also need to be taken care of. So in that case, it found Indians 2,403 and non-Indians 17,000, approximately 7,600. And finally, from CMU, we have 1,100 academicians of Indian origin who are there in our database. Now, results of the URL which we have skipped, means irrelevant kind of URLs. In Stanford, see about 2,51,000. Okay, or rather 25 lakh, rather 25,11,000 in Stanford, irrelevant URLs. Same as the story in Wellesley, then Yale. Okay, so these many, and CMU was the highest. That these were the irrelevant kind of URLs we could skip, and we can narrow down the time. And the same kind of results, number of faculty links received for all these, Yale, Wellesley, and Stanford, you can see. And ultimately from, see, these long and long bars, okay, for relevant and irrelevant. But ultimately Indians found these are this. Okay, for this information, this slide is just to show that how useful these naive-based classifiers, naive-based filters have been for this data, huge amount of data. Then in our database, the current status is that we have 23,475 Indian origin academicians from 4 countries, UK, US, Canada, and Australia. And PhD scholars found are 3,467, and master students are 1,000, about 1,500. Okay, 1,500. These master students are there. Now, these are the different milestones that Indian surnames. Now it is updated. It is about 10,000, and list of institutes, of course, 2,000, and Indian cities 300. Now, see. I just want to discuss here with you, see the importance of surnames and how they confuse you also in classification. Okay, when it is this classification at that stage here, okay, when you will use these classifiers here, Indian names especially means I am not biased. If it is a kind of that, because so much diversity is there, our country is not that small. It's means 130 million. If means these kind of people are there, so then it's really difficult to classify them into few surnames, and then few names are that it is very difficult to classify even the surname. Especially in southern India, if you see, names are very long also. So that is also a problem. And then, problem in a way for classifier. And then few names are there, especially from say state of Kerala and state of Tamil Nadu also. Okay, where our citizens follow Christians. They are Christian also. Christianity they have adopted and they follow that. And then means some names were like kind of that name was I think some D'Souza, and then one name was C.B. Thomas. Okay, then Harris was there. These surnames were there. So now see for crawler, it's really difficult. Even for we also. And then one name was that Roy. Now see Chanchal Kumar Roy. We thought of that. It's an Indian name. But ultimately, we found that he is a Bangladeshi. He is also Bengali, but from Bangladesh. He is in University of Saskatchewan in Canada. So, I mean, that is very difficult. Manually, if you are doing, it's a something different story. But when program on your behalf, that program is doing, that focused crawler is doing, and it's using those all algorithms. So then this machine learning, it really plays a very useful role. So when you can train your crawler that it will classify, that how it will classify, and then of course there were certain false positives also, especially in case of you can say that especially the faculty from the Muslim faculty, they are from Bangladesh also, they from Pakistan also, and of course a large number, rather huge number, more than Pakistan, that Muslims are in India also, and they are really contributing as faculty members there. So in that case, it was very difficult for we people to classify. So then we need to go to various social networking websites, LinkedIn, then maybe to these Facebook also. So we tried with that also, and ultimately at last we left with around 1600 names. To them we have sent emails also that we could find your name in this crawler, and these are the things, and this is the importance of the project, and you please let us know that do you belong to India. So people who were Indians, they mentioned, but some others were there, they mentioned that this study is very useful, and even if we don't belong to India, we also want to participate in this, so if you can. Okay, so and Indian origin people, they have written us that they belong to this state and they really want to contribute. You Malayali people from Kerala, they have written to us, and one faculty member from Punjab, he has specially written to us that I want to help the schools in Punjab. So this all data, it's there, and this data DST want to use because this project, we contacted UGC also, AICT also, then Association of Indian Universities, AIU, and then DST or Local Project Advisory Committee suggested us to contact Ministry of this External Affairs. Okay, then they guided us to PIU, Persons of Indian Origin. You can check that. But then nothing was available. AIU, Association of Indian University, had a list of 15 people, and they used to rotate these people in different committees. Okay, but you think of that if it is national education policy, new education policy, or any kind of policy we want to create. So to what extent these people can play a role? Gyan scheme, I told you. Then today, it's a by chance, it's a coincidence that there is a program of DST and DRDO, WebHub. Vaishvik Bhartiya, I think that kind of WebHub, you can just visit that website. And in various learning and AI is also one of the domain in WebHub. So 18 or 19 different domains, and they have the names of 5,000 experts from Indian origin experts. Because earlier during this week, 2nd October, because 2nd October, our father of nation, his birth anniversary. So government of India used to celebrate that Pravasi Bhartiya Divas, Pravasi Bhartiya Divas, because they do consider that Mahatma Gandhi was the greatest Pravasi that who came to India, that he came back to India and he changed the lives of Indians. He brought the freedom to Indians. In this week, Government of India used to celebrate the Bhartiya Pravasi Bhartiya Divas, and used to invite them. This time it is that those 5,000 people, they are along with the DRDO and DST, they are celebrating this Vaibhav. And under 18 to 20 disciplines, different discussion committees are being formed so that they can help in different projects, different Atmanirbhar schemes, Skill India. Okay, one of this program also already you are undergoing the skill development. So these people, because if these many academicians are there and they are very senior, and the kind of equipment, the kind of projects they have, and they have access to that kind of machines, okay, which are not available in India. So our students, our faculty, they can collaborate with them and can find out various search avenues. And even if blog we are creating, so through that they can discuss various positions they have, maybe for PDF, maybe for various employment opportunities, different research positions, okay, PhD slots they have, master slots they have. So our students, they can get benefited. And different government schemes also, like Fulbright scheme is there, Singh Obama Treaty is there, Shastri Institute of in Canada of Indian Studies. So they do, because this information is not available anywhere. So, and if our own state people or our Indian origin people, if they are there, so you can contact them and even explore further the opportunity. Now you can see that in UK, the number of academic institute URLs that we have crawled, they are 338, and it is Indian academicians we found around 3,400, and from Canada we could find around 3,000. It's about 1,200. Now it's more, and maximum is 16,000. Now it's 16,000 and more than that even from US, and all others are many other countries. I will show you. This is G20 countries, because earlier means, our government focus was there on G20 also and BRICS countries also. We finished the study in 2019, and after that now we are working on BRICS countries. For these 4 countries we finished in 2019, and in October 2019 we started with BRICS countries. Now we are doing it BRICS countries because now focus was shifted to BRICS countries. So these are G20, and from G20 also certain URLs we have already retrieved, and we will be working on that. And out of G, few we have already done, this US, UK, Australia, this already we have done. And in BRICS, this Brazil will come, South Africa will come, China will come. So all these are also there. Okay. So then few other countries also. These are the count of data from few, you can say, universities. So you can see the Indian academicians. Okay, total Indians found were these, but Indian academicians were these, and 85 students. Means from this also we can find the trend that which particular universities Indians have preferred. I'll share it with one PDF also. I'll share with you that brochure. I'll show you. From that, through data mining, we have created certain information also, and through that we will come to know that which particular university Indians have preferred, which particular discipline they have preferred. Okay, how Indian female academicians they have preferred. Okay, so these all universities, we have few universities we have considered, and you can see also, and then PhD scholars also. This is the UI that we have, a website we have created, and within next 15 days it will be made public. It will be inaugurated by Government of India in these web activities only, and this will be available, and you can just explore this. Then those academicians and users, they will have their accounts also, so that they can participate in discussions. Okay, different project groups they can create. And they can see. These are the Times top 10. Okay, they do the rankings. US and Times top 10 universities, they do rankings, and through those rankings, if we see that in CIT, California Institute of Technology, the number of PhD scholars are these. Okay, and if you see in the next institute, that University of Oxford in UK, so these many PhD scholars are there. So you can see that in Princeton there are 128. So that way, country wise and university wise, we can find out. I told you that any database, if you will create, after some time, it will become outdated. Okay, it will become outdated. Any database. So you need to continuously update that database, and means updation is not that easy. Okay, you can see that if 23,000 and it is about 30,000, if these entries are there in the database, somebody may switch over from one university to another university, because in that there are complete contact details are there, even their email, their phone number, if it is provided, their office address, their specializations, kind of projects they are working on, their research publications, everything is there, okay, in that website. And in database these entries are there. So if 30,000 are there, so there may be that every day people are changing their place of work, or their interest will add, or something kind of. And if it is a PhD student, their status may change. They may join as assistant professor, master student may, their status also may change. So we need to keep that information fresh. Okay, but it is very difficult. It's a very challenging task. So that also what we are doing is we are doing it automatically. So we created one, the change module, and that it's in testing phase. And that change module also means it will be using machine learning. So through that means the information about the academicians will become outdated, as I told you. And it's not that every day we can keep this change module active. That also will be just wasting effort, wasting the computational time, wasting internet bandwidth. That will be just wastage of effort. So what we can do, we can set a periodically, maybe after 1 month, maybe after 2 months, we can send this change detection program. Okay, the remote sources are managed autonomously, because crawlers autonomously they will move. Okay, and these programs also, and update independently local copies, due to which the part of the local copy may get out of date. Okay, to decide the preference order in which URLs are to be revisited. That also means if it at all you have to detect the changes, you have to revisit that URL, and then you have to design a revisit policy also. Okay, determine type of change and amount of change. On the basis of that, revisit policy need to be devised. Important to design a good refresh policy that maximizes the freshness of the local copy. There is a trade-off between coverage and freshness. Okay, because it's not only that you need to keep information relevant and fresh. There is coverage also, because as I told you, that if crawler will visit any site and where it's 20 crore or 2 crore URLs are there, so you can just judge well that how much time it is required, okay, to visit that, and then to compare the contents. Then in this policy, change detection policy, you can see that we have created that MIS, and from that it will pick up list, specialization, and email. These all it will retrieve from first the URL list all, and then one by one each and every row we have to retrieve. Then visit that URL list one by one, match name in database with the current value. It may remain same, or if the person has left, the new also be inserted. So yes, mark the name and to the admin. We can replace automatically also, but that is really cumbersome. So chances of ambiguity are there. So what we are doing is that if there is a change, inform the admin. So admin can log in this, and on admin dashboard, all these mails, all these signals, they will be there in red, green, or blue. That will be there. So that it is for his or her attention of the admin, and then regularly can visit on the basis of the amount of change. Now, if it is no, then mark the name field green and manage other fields. Other fields change detected in the other fields. If it is no, mark the fields green. If it is yes, mark that field blue and report to the admin and save the results with that on this particular date you revisited that URL and you found these changes. So those changes, they can be compared on the basis of term frequency or on the basis of their contents. So they can be compared and they will be retrieved back to the database in mail, or mail will also go to the admin, and on dashboard also that will be displayed that these many changes have been reported. Red are these, green are these, and blue are these. So they can be classified. Dashboard for changes also. Now it's a black and so the colors also when it's mentioned. See green, blue. Okay, the red is there for Aarti Dwivedi in MIT. Okay, means do not contain some. There is something kind of. Let me see. Does not contain correct information that compared with that. Say in any other red. This is red. This is Patel, Aarti Patel. It's again the same, I think, or to some other. Name is same, but it has taken to some other page of the same university. Then see red. It's a Aarti Shah. Earlier was Aarti Patel, and now it's Aarti Shah. Okay, so that's why it has given red. Okay, maybe that some lady got married and then has changed the surname. So these kind of issues are there in that. Okay, if we just discuss it, looks very easy. But when it is on your behalf, that crawler or any program is going there and is retrieving that information and comparing those contents, it becomes really, really difficult. And when I told you that 2 crore links are there and crawler means day and night, it's crawling that information. And I remember that the largest time was 23 days that crawler continuously university, I think Stanford or MIT, I think. So it continuously it was working, and 23rd day we could get the whole data, and then we supplied it on to the different filters, and we could get. So it's a very huge task. Now let's see the glimpse of, because it's not an exhaustive list of challenges. Only few I am showing you. Ambiguous information. See, in Indian context, we write PhD scholars, and in most of the foreign universities, it is written as graduate students. Okay, and now graduate students, they can be masters also, and they can be PhD students also. So that will be also a problem to classify. Okay, now see Sneha Balasubramaniam, graduate teaching assistant, graduate student, joined department. So means that information becomes confusing. Okay, that becomes ambiguous. So then you further go to next level depth, and then you have to again analyze. So crawler really sometimes get confuses and then decides to go to the next level of depth. So that way it becomes challenging. Then it is incomplete information is there because we need photo also, because photo is also there in our database, and then addresses, emails. Okay, all these are required, but incomplete information is there, like Arvind Balakrishnan, graduate student, and then there is given my page. Okay, my home page. It may take you out of this domain. Okay, he or she may have, say, arvind.com or Arvind my page, Arvind Balakrishnan my page.com. So if it will go out of that, then it's very difficult to come back, because we have mentioned that it has to remain in the high level, that domain, that it will remain in that. Missing information. Some departments of a university does not list the PhD student in the particular department. Example, University of Alberta. For Department of Medical Microbiology and Immunology, list of PhD students are available under this. See, it is under, it's any other kind of URL. But yes, of course, Alberta is there. But information is somewhere else. Staff, students, see, whether it is staff or it is students, it's a faculty or it's a students. And then you will get to here. For Department of Biomedical Engineering, Economics, no information about PhD scholar is there. Similarly, for Dalhousie University, information of PhD scholar is available for biomedical, biochemical, and medicine. But same information is missing for School of Architecture or Agriculture department. I mean, few of the department, they are listing their PhD students, others they may not be listing. So that is also a challenge. Then for certain universities, direct faculty profile and directory link are not found from their websites. In such cases, Google search is done to search for the faculty of the university by using keywords such as professor, means all faculty keywords, professor, associate professor, assistant professor, etc., to look for the faculty. This method of searching is very, very time consuming. Okay, means you will first find out that at which depth it is available, and then in between you will stop the crawler and then you will feed these. In certain cases, two different names of the university college are being used, means aliases are there for the. It's confusing. One being the common name. For example, Pennsylvania State University, commonly known as Penn State or PSU. So that also for crawler it creates problem. Manually it's okay, but when it is by a program, a crawler, then it becomes difficult to classify. Now, what all academic URLs we got? Some of them are dead URLs. Now your crawler will go there and will end up there infinitely because there is nothing. They are not there. So then we had to train our crawler in that way. So to come back, many were there which were dead URLs, either closed or they have shifted to some other domain name. These kind of issues were there. Now, means the present status is like 3 crawlers we developed, and naive base is also there, and sport vector machine based also, and different. Then we are now trying ensembles also, machine learning. If you have understood that different algorithms, if we combine and hybridized kind of ensembles that we are using. So graduate projects, I have another PDF also, that also we will discuss. Okay, we have about 20 minutes to discuss that. So 26 undergrad students, they have completed the project in this. Because if any faculty is working on a project, it's ultimately in an educational institute that students will get benefited. 7 master theses and 3 are ongoing, and 1 PhD is also completed in this project on these crawlers. And even we are working on, because these crawlers, they were retrieving information from only the home pages or faculty pages. Okay, they are not kind of hidden web pages are kind of already calling web pages. They are behind certain forms. Okay, means you will click something or you will fill something. If it will ask you, say ID number or something, you will, or login you will give, and then it will move to further. Like on Amazon, if you go home page and then it will ask you for the item, which item you will fill there or you will select there, then it will take you to certain other. I mean, these are dynamic kind of indexing. So those index will be, the pages will be indexed on the basis of your query. So if that will be there, for that you need queries also. So automatically some queries will be fired, and those queries need to be optimized so that you can index the maximum pages available on that particular academic website, so that you can retrieve maximum information. Okay, and like if it is thesis, abstracts are there, so they'll be on the basis of one discipline you will select and then go. But if it is in my query, I will feed all disciplines, then it can retrieve automatically, that crawler can do. Otherwise, crawler will not be able to select the discipline because it will stop. Some fill-in is required. So that is on the basis of that deep web crawling or hidden web crawlers. They are there. But of course, we will not violate logins. Okay, that will not be done because crawlers can be stopped by robot.txt at the websites. So that we have to then configure that there is no conflict of interest and we are not going to any hidden information, or we are not crawling the pages which are hidden behind logins. So that we are not doing. Okay. So these are the kind of publications. A few essay publications are also there out of that, and then in reputed international conferences also this information was there. So first part is this, related to this, but then my lecture's second part is also there. Okay, so in between, if you want to ask something, anybody want to ask something, so that I can. Okay, somebody has asked that what do you mean by term frequency here? Okay, let me tell you. It's a standard meaning, term frequency. Term frequency here is like any keyword you have used as a term. Okay. Means whenever you search any information, so you must have thought sometimes that when you give in Google, say Chennai University, it may give you that in 5 seconds, millions of pages it has visited, and it will list you all. And on the basis of your browser, that 1 to 20 or 1 to 10, it will show you in first page. Then it will show you all pages in the bottom. First page, second page, third page, 1 to 10, it will show you. Then you can press the next also. Then how it will be decided that which one will be the first one, first page? That will be the crawling policy. Okay. And the very basic kind of crawling policy is the term frequency, means how many times that particular term occur in that particular page. So it will consider that if many times that term is occurring, okay, that professor or academician or say Indian, okay, these kind of student, if this term is occurring many number of times, its frequency is much more. So it will bring on top, okay, on upper level pages it will bring, and all other can be less relevant, and so that means these are the that are there. So term frequency is one of that. I hope it is clear, but if any other doubts are there, you can please do ask. Okay, and now I want to share another, let me see. Is it visible to you? Indian origin academicians in foreign universities. This page is visible? Anybody can tell me, please?
Yes, sir. Yes, sir.
It is visible. Thank you. Thank you very much. See, this is one, you can say from that database, this has been created. From that database, we have created this. So it is basically Indian origin academicians in foreign universities with the DST. We have created this brochure. It will be launched, as I told you, next week's time in the web of events only. So this will be the URL for that. if you are interested, you can note down, or I'll share it with the organizers. So what we have done is we have provided this customized search there. You can search according to the academician name or foreign university name, or you are interested in, say, computer science department, or you are interested in, say, chemistry. So you can just give that department, or you are interested in only Carnegie Mellon, or you are interested in only Concordia University or Sydney University. So accordingly, those all such options we have given. Then certain filters are there. University, say you have passed from say Madras University, so you have given that domain, like say chemistry you have given. So all academicians, scientists in all these 4 countries in chemistry discipline, they will be listed. But now you want to find out from your university, say you are working in Madras, or you are alumni of Madras, and you want to see how many my classmates are there. So then you can filter it on the basis of Indian university name, and even on the type of further in chemistry, any say organic chemistry or inorganic chemistry or any other type of chemistry. So you can narrow down. Then all academicians of a particular department can be listed. As I told you that CSC or artificial intelligence, you want to search all these. Okay, so in Science Direct, how many disciplines are given? So all those disciplines have been considered in this. And then there is, because email ID, their research areas, their projects, okay, they have been mentioned there in the information which is provided on the website. So you can contact directly also. There is nothing kind of that through this, through DST or through we only you can contact, no, or through only those discussion forums, blogs you can contact, no. Their contact information is available. You can contact directly, because you may have n number of different ideas through these contacts, how you can exploit this information. So that's up to you. You can do that. And then showcase the achievements, as I told you that Indian women academicians also that we have shown, and in different disciplines. So then means this all information will enable you for policy making, maybe for projects, deciding projects. There are different kind of there is in UK there is so UK and US both, this is there, and in UK and Canada there's Commonwealth scholarships are there, Newton Bhabha policy is there, research is there. So in that there's a prerequisite that one academician from UK and one from India, they can collaborate and they can submit the proposal. Now see, to how many academic institutes or to how many Indian universities these facts are known? Very less, very less. It's only IITs. And that's why they have projects and they flourish. Okay, all other, they don't have. But now it is not that in the age of information, you cannot say. Because if you see the CEOs of Microsoft or Google or these all, so essentially they are not from only IITs. They are from other institutes also. And they are doing excellent work they are doing in that area. May not be only in IIT, other disciplines also they are doing. So from that point of view, it is that in many ways, policy making or for teaching or for anything, and see in this new normal, the way I am delivering this lecture, so any professor from anywhere can deliver that lecture. Okay, for Harvard convocation, this Google CEO delivered from his house, from his garden. He delivered that talk, convocation talk. Okay, so it is that this new normal has brought, if we ignore those all negative things, so has brought many things positive also. It has changed the way people will learn and will teach. Now, in output, when it will be available, in input, I told you different kind of home pages of various universities we have crawled, and Indian surnames were there and Indian city names were there. So all these were there. In output, these all will be available. That name will be there, contact details will be there, from which Indian university they belong to, which UG degree or PG degree or PhD degree they have done. And if their year of degree is mentioned, then that will be there. So then discipline, then department, country, then their research specializations and their designations and their experiences also that will be available there. Now see Indian origin admissions in various countries. Okay, see in US, and this is outrightly a different kind of a bar is there. As I told you that 16,000 are there, and rest of the total sum these three, even that is less than only US. Okay, the reasons you know that Indians earlier they migrated to only US, and later on they started to the other countries also, but earlier only US. And the examples you have seen, I have shown you. Subramaniam, okay, then another name was also there, Patel is also there, Shah is also there. So many have gone. It's not only that Punjabis or Malayalis they have migrated, all have migrated, from all over India, people have gone. We have seen that. It's Indian origin academicians by various disciplines in US, you can see. It's all through data mining and machine learning algorithms that we could get this all information. You can see that IT India is top, and IT people are doing there in US wonders and all. But you will be surprised to see that we see medical health sciences, doctors, professors in medical profession also. Means Indians are there, and out of that, it is females and 60% are males. Okay, the most preferred discipline in US is medical health science, then engineering, and followed by social sciences. Now, if you know that through this study, PhD could find out that why means in your region that northern part still social sciences there, but in if you come to this northern India or central India, we could not develop social sciences subjects. It's not there. Now only that India has decided to open on the pattern of IITs, Indian Institute of Technologies. Now they are opening Indian Institute of Social Sciences. Okay, when that policy is there in new education policy, that now government is starting Indian Institute of Social Sciences. So you can see from here that all good people in social sciences, they have migrated to the US, and computer science is far behind than these life sciences, business management, chemical sciences. I mean, it's all. It's not any discipline that has not been touched by academicians in the US. And then comes preferred institutes by Indian origin academicians. You see Cornell University is on top. And in that also you can see that males are also there and females are also there. Okay, so it is, but you can see that the preferred institutes among Indian origin male, it's Cornell, Stanford, and CMU. And for females, preferred institute of work among Indian origin females, it's Cornell. Okay, Cornell is there, and then Asian School of Medicines, because from medical sciences, females are there. And you see, university, you name any top university, it's there. Okay, Asian School of Medical, Texas, Carnegie Mellon, Rice University, Duke University, University of Utah, and then Chicago University. All universities are there. And story is same in UK also. Okay, see the disciplines, again, it's a medical health sciences. That's why you can see that to what extent we could develop of medical institutes. Okay, and the quality in medical institutes, and how many IIMs we have, Institute of Medical Sciences, and then what kind of difficulty they are facing in getting the faculty in medical institutes. Okay, this is the reason it's given. And see, number 2 is because UK really, this Oxford University, it's really that social sciences, It's again, it's on number 2. Engineering is now on number 3. Business management, life sciences, computer science far behind. Then chemical sciences and mathematics. Okay, so all these disciplines are there. Now see preferred institutes. Imperial College London, University of Oxford. See all this social sciences people, they are there in Oxford. Then Cambridge and Oxford, yes, both. Then see, all universities are there. University of York, University of Liverpool, all are there. Story is not different in Canada even. See, medical health sciences, you can see again, continuously, US, UK, Canada. The most preferred is, it means all good doctors, okay, maximum good doctors. I won't say all, okay. It's not that the people are, maximum are here, but who have migrated among them, maximum. Then again, sciences in Canada. You see, engineering is far behind. Then business now, yes, in Canada, all good business schools. Indian faculty you will find. You'll find number of Indian faculty. Then universities in Canada, which our Indians have preferred. Then top university in among top 10 KUS universities. So Indians are there. Who is their top university? So maximum Indians are there only. Then Western, University of Saskatchewan, then McGill. Okay, in engineering, McGill is good. So Alberta, McMaster, Calgary, Ottawa, Dalhousie, then Waterloo. Okay, and engineering again, people from India. In engineering, Waterloo is also, people are there. See again, in Australia also medical health sciences. So all these 4 countries, medical health sciences is the most preferred discipline by Indians who have migrated. Then in Australia, engineering is the second number, and good business schools also, Indians are there. Social sciences again, okay. So the story is not different in all these 4. So now let's see the preferred institutes. Sydney is their top university. So University of Sydney, Australian National University. This is Monash University. Then Queensland, University of Newcastle, RMIT, New South Wales, Curtin. Means all their good universities, they have Indian faculty. Now, the discipline-wise, now from all these 4, see, medical health sciences is on top, as I told you. Okay, and it's not that females are behind. Females are also, means they are participating like anything. And social sciences, see, it is almost 50-50. Okay, social sciences, 50% female academicians and 50% male. So engineering, okay, it's dominated and by male people, and that can reflect in our policies also and our engineering intake also. These days, it's okay that girl students, they are coming, and now IITs also have the girl students reservation also. But these data are that these people are maybe who has migrated 20 years back and 30 years back, and now they are professors there. So you can just easily assess, and it reflects policy also. Now in business also, you see, it is also then life sciences and social sciences and medical sciences. You can well judge, you can estimate that why we are lacking. Okay, why we could not stop them, and we could not nurture that talent here. So now you will see in times to come that based upon these data, that policy decisions will be there, and these people will participate in those policy making. See, it is for also again for your surprise that these are the Indian institutes who have contributed to Indian origin academicians. See, top is University of Delhi, then IIT Madras, University of Mumbai, because engineering is mostly from IIT Madras. It's because of their existence, also long existence, and University of Delhi maybe because of their vast, large number of disciplines they provide. And University of Calcutta, University of Mumbai, University of Madras. Okay, means it's not only IITs that they are contributing. See, these state universities, these 3 state universities, and the University of Delhi is on top. Okay, they are contributing. Disciplines you have already seen. And in IITs are also there, BITS Pilani is there, Jadavpur University is there. Okay, because Jadavpur and this Calcutta University for especially for social sciences, these people are there. Okay, means these are some glimpse you can say of that data I have shared with you, and all related to crawler that we have already done, and the methodology also we have already discussed. Okay, so this will be available. This will be launched in next week by Government of India in Web of Activities.